Hello.
Hello,
Hello.
Hello?
let's wait for a couple of seconds. I believe at least one of us will join, right? Ah, just go. Okay, welcome to the sixth PeerDAS breakout call. The agenda and mini notes is here. We can start with the client updates. Anyone want to share the recent updates from the client side?
Yeah,
Prison?
I can give an update. For us, we have been working on clearing up some tech debt from basically trying to get a PeerDAS into a mergeable state to a developed branch. So we've been trying to improve our test coverage on a lot of the PeerDAS specific parts. We have implemented the blob sidecar support for PeerDAS. So if you have at least 50% of the columns, any API consumer can just get the blob from that. We've also been looking on strengthening our data column validation, so improve pipelines so that any columns that we get from gossip or that we get from other peers are correctly validated. And also, lastly, we have been fixing a few bugs with Electra that came up. So Electra with PeerDAS flushed some bugs out in Prism with regards to how blobs were used. So we had a bug where Prism would drop blocks with blobs and the chain would stall. So that was one bug that we focused on last week. And yeah, that is all for now.
Thank you. I think we were testing if the rebest with Electra works for the PeerDAS.
Yeah, so for us, what we did was that we try to make it extensible in that you could have Prism start with either Deneb or Electra and it should work fine. But last week when we tried with Electra, there were a few bugs that we found, which had nothing to do with PeerDAS, but actually with our Electra branch. So that's been fixed now, and with the current PeerDAS branch, you can start in Deneb or Electra.
Thank you. Um, any other clients? Lodestar?
Yeah, I can go for Lodestar. So, as such, we are working on the PR to dissociate the subnet from groups, and that is something that sort of we want included in the next DevNet. And based upon what the consensus is for rebasing PeerDAS on Electra, we'll also work on that then.
Thank you. And then Lighthouse?
Hello. We have fixed a few bugs, including range sync. So Lighthouse can now sync network, and we've also fixed an issue with our sampling, which was sending excessive requests to a single peer. That's fixed now. So we've now disabled sampling by default. Other than that, we have been focused on merging our DAS branch changes into our main branch. I think we're probably around 50 to 60% through. Hopefully we can have that done in the next 2 weeks. The better, so we can speed up our development progress. And other than that, we've made some progress on the optimization to fetch blobs from the EL. It's also known as decentralized blob building. So for supernodes, we fetch blobs from the EL, and we build the data column sidecar and the publisher network. We've done some testing on this, and the testing shows that even Proposer with limited bandwidth, they don't publish all the data columns. They can still propose a blob fine with the help from Supernode on blob building and blob propagation. So that's looking quite promising. I think our next step on that will probably try to increase the blob count. It might be slightly challenging because of the way we currently compute data columns and proof. It takes about 200 milliseconds per blob for my machine. And I think then there could potentially be some memory allocation issues on stack. So yeah, so increasing that blob count could be something that's a bit challenging with KGG library. I'm not sure if any client has tried testing increasing blob counts. But I think it kind of sucks a little bit in the 1D one-dimensional PeerDAS case because we need to build the entire column. So it means we can only compute or reconstruct when we have all the blobs. We can't just partially do it because with the 2D scenario, we can have each node just randomly select a subset of all blobs and compute just a subset rather than computing the entire blob. So that's going to take a long time for 32 blobs. So that's something we hope to solve. But again, with 1D PeerDAS, that's a bit challenging. Yeah, so this week we will focus on trying to get our checkpoint sync working again for PeerDAS and also prepare for the next DevNet. That's all from Lighthouse.
Thank you. So regarding the blob count, what was the parameter you used?
I've tried to change it to 32, but I haven't got it working yet. But I can see that it's going to be slightly challenging because I look at the benchmark for the Rust KZG library, and it takes 200 milliseconds per blob. And currently we don't do any parallel processing. So like 200 per blob, if we make it 32, that would be like 6 seconds or something without any parallelization. So we probably want to do some parallelization there if we can. Yeah, I think it just needs a bit more testing. just a potential challenge I thought it's worth raising.
Thank you. And granting.
Hello. So yeah, our fellow that was working on PeerDAS made some fixes, and essentially we are waiting until the state, and likely it will be the next Devnet, which will not there will not be a requirement for sampling. If this is still the plan, and then we will try to join the network on the next Devnet. So that's all.
Thank you. So just to be clear, the next Devnet is the one you are joining will be Devnet 3, right?
Yes. Is it still the plan to kind of remove or not make a requirement of sampling in Devnet 3?
I think we will finalize it today, but
Okay. Thanks.
thank you. And then Nimbus. Anyone from Nimbus here today? No. Teku.
Yeah, we finished adding full metadata with free support. We'll merge it today. Also, we make reconstruction of those sidecars, so you could get it from REST API, but only if you are Supernode, if you have first 50% of data columns. Merging it today probably too. And we fixed a bug. We had an issue when we were trying to retrieve column. We were not trying to retrieve it from all the peers, only trying first two, something like this. Fixed it too. And we have added all validations, and now working for fork choice to be spec compliant with alpha 4 version when we check only custody. And regarding Electra, we have not started to move to Electra, so we will start probably after Devnet 2 launch. That's all for us.
Thank you. Okay, any questions for the client updates? I believe gone through all the clients. So the next one is the Devnet discussion. So I'm reposting Barnabas' proposal as a summary here. For 1 second. Okay, please check the chat as a link. So basically the proposal is to for the Devnet 2, we have the previous we have based on the previous spec alpha 4 and then use Devnet Genesis, no Electra rebase. So one important item I want to check again in the chat is we okay with including PR3870 in Devnet 2. This is the link of the PR. So yeah, I think for the reactions from this code is like people do want to have this feature, and the book choice update is trivial compared to the previous version, so it's okay to include the whole feature into Devnet 2. If you agree or disagree, please give some reaction here now.
I had a question. So this PR also includes a config change, right? So one issue for us is that we always test with the consensus spec config. So if this is not in Alpha 4, our tests will start to fail with this.
Right. So I think we have two discussion. One is, do we want to include this configuration change into Devnet 2? And if it answers yes, then I will cut the release for it.
Okay, yeah, that'd be good enough for us then.
Okay, good. Yeah, and any objections?
So you're saying we will include the config change, or is that a separate discussion?
I think we will include it if people are okay with it. But Francesco, would you like to explain the parameter? I mean, changes.
Yeah, I mean, this is actually something that's been kind of yeah, in a bunch of PRs, I think, since Kenya, and it just never ended up being in a PR that was merged. It's just that yeah, we needed to increase the number of subnets because we want to increase the custody requirement. Originally because we wanted to do this trailing for choice, and we kind of needed the custody part to already basically give enough security, and now we literally don't have sampling, so the custody part really does need to be kind of secure in itself. So I think it would make, yeah, it wouldn't make sense to still leave this for a future update. It's quite central to how custody is supposed to work. And like, yeah, it's something that we kind of had agreement on, like basically already in Kenya. So I think, yeah, we should just include it.
Thanks, Francesco. Okay, then, so we now finalize the Devnet 2 scope with Alpha 4 plus its Devnet based, and then including this PR, and we will cut the Alpha 5 release soon. And client teams agree with the timeline that Barnabas proposed. I think it's by the end of this week. Good. I think it should be a small release, and I can make it, say in 24 hours to cut the new release for suspects. Okay, so any objections for, okay, Devnet 2 by the end of this week. Okay, then it's Devnet 3. So it would be another spec release number. We will. Do we want to make it as a Electra rebate version? Anyone want to?
I think all client teams
Sure.
indicated that in 2 or 3 weeks they could do a Electra rebase. So I would actually push for Devnet 3 to be based on Electra.
Any objections?
Yeah, I agree with Barnabas, and We just need to test it out on our side. Yeah, it should be okay.
Okay, great. So definitely 3 will be the Electra rebase version, and we discussed previously it will be a main subnet decoupled version. Yeah. Can someone link the PR to the chat? I'm trying to find it. Yes. The decoupled network subnet. Thank you, Jimmy. So we will include this PR. Yeah. And Barnabas, you want to launch it in 2 or 3 weeks?
Yeah, I guess that's just an estimate timeline. Let's see how Devnet 2 is going to go. If Devnet 2 is not very stable, then I think we're gonna need to delay it a bit further.
Now, would you like to talk about the activation flags?
Right. So we had I think a couple of months ago we were talking about possibly activating PeerDAS with a different way instead of doing a EIP whatever fork version and fork epoch. We could do just PeerDAS activation epoch. I'm not sure if this is still under discussion or what should we do about that. But I think if we do an Electra rebase, then we should have a way to trigger trigger PeerDAS independently still. Not just automatically activate PeerDAS with Electra.
Yeah, so for us, the PeerDAS activation epoch is still separate from Electra. Just that in the testing config, we have it the same as the Electra fork epoch, but if you do need to, you could have it, Electra plus 20 epochs in the future or something. It'll work the same way.
Nisha, are you using the PeerDAS activation epoch or are you using ERP 7594 block epoch?
So from what I understand, EIP 7594 is what is in all the configs, so that is what we're using.
Right, so currently the spec says EIP 7594 fork version and EIP 7594 fork epoch. And the way we do the PeerDAS activation is by setting the fork version to Deneb's fork version, and setting the fork epoch to Deneb's fork epoch. And in the future, when we do a rebase on Electra, then we're going to trigger it with the EIP 7594 fork version equals to Electra's fork version, and the fork epoch should be equal or be greater than Electra's fork version. Fork epoch, sorry. But the fork version should be the same. So the question is, do we want to keep it this way, or do we want to possibly get rid of these 2 variables and introduce a new one called something like PeerDAS activation epoch, and get rid of the fork bit completely?
I think eventually we can get rid of the block epoch, right? When we're ready to launch PeerDAS with Electra. I don't see any clear benefit of changing it at this point, unless I'm missing something.
It would be just a cleanup, but yeah, we can totally keep it like this. Then let's not change anything how we activate it. Let's just keep all the same stuff as it was before. Okay.
Thank you. All right. So now we move to the spec discussion. Does anyone want to talk about some specific PRs or spec changes? And any questions to the KVG libraries?
How many blobs can we support?
Sorry, Jimmy, you were cut it.
No, I was wondering, has anyone tested like how many like what's the number of blobs we can realistically support in a block if we just ignore the networking stuff, just to focus on the crypto library in terms of CPU memory and time. Sorry.
I mean, I think at least the C library should be like which functionality are we talking about here?
I'm talking about compute cells improve and recovery cells improve.
I see. Okay. Let's see. So I think. Okay. I mean, I'm not sure. I think what numbers are you interested in? Like you want arbitrarily many blobs and you want to know the time it takes, or what, or when the library is going to explode, or what?
Yeah, basically, like I don't need arbitrary numbers, but if we're aiming for something like 32 blobs, I think it'll be interesting to know like how much time it takes and CPU and memory requirement. Because I think at the moment I've tried running the the Rust ETH KZG library benchmarking on my machine, and each blob take about 200 milliseconds to compute and to recover.
Yeah. Yeah, and you're wondering, okay, so, and you are wondering, like without, like you want without parallelization. I think without parallelization, it's going to be a linear thing. Like, you know, you put 2 blobs, you're going to get 400 milliseconds. But you are hesitant about using parallelization?
No, I'm not hesitant. I think we probably need to figure out how to like to see like how parallelization helps. I think the benchmark for the Rust KZG library also tests parallelization, but it doesn't seem to improve a lot. So maybe I was looking at the wrong number, but I can try to confirm afterwards.
I would imagine it's like completely parallel. Like if you have 2 cores and you split it you split 2 functions into 2 cores, they're just going to take the same, like you're going to do 200 milliseconds for 2 things if you do them in parallel.
Right. So if we have 32 blobs and we can do 8 in parallel, then we'll need at least then 800 plus milliseconds, right?
Yeah, that would be what should happen in theory. If this doesn't happen, it's something we should know.
Okay, cool. Yeah, I'll test it out. Yeah, I think maybe I was reading it wrong. I think the numbers just showed me 200 milliseconds. I guess it's for one single block. So yeah, I'll try to confirm. Maybe I was looking at it wrong. If it's perfectly
I think after a certain number of blobs, we will need to do parallelization anyway. So I think figuring out what's the right parallelization strategy is needed. And then if the numbers you get out of that strategy are not good enough, then we should figure out something out.
Yeah, because I think if we try to increase above maybe 32, then it feels like we would probably need like distributed block building, because if we try to build on one machine, and each machine, let's say if the limit is up to 8 parallelizations, then it may still take a long time unless we assume that every node can parallelize more than 8. So I think it's
Right.
something to think about. Yeah.
Yep.
Do we have a
Yeah,
way now to decouple the blobs, by the way? Because we now have the max blobs per block config parameter in the config YAML, and we have added support for this parameter in kurtosis as well. So you should be able to just play around and just pass in more blobs, but I'm not sure if the EAs will support that.
Yeah, I think the EL will need some changes as well. I've been trying to play around with Lighthouse and Ref. I haven't got it working yet, but I think on the EL side it should be quite straightforward. Just change the constant, I think.
We
I
had
think it
this,
depends on the EL. Some of them have it baked into the library, so it's compile time. So they might have to make a change there, and you might need to use a different image each time.
but we also had a PR that would change how the blob count would be passed around from between the CL and the EL. I'm not sure if that made into
Exactly. I
the
think
IP or
Alex was
something.
working on
Yeah.
that. I think that's also the right way to do it, but yeah, I'm not
Exactly.
sure where it is right now.
Yeah, just one more thing to add. I think with the limits on computing the blob proof, if we really want the distributed blob building, I think that would be a lot more efficient in the 2D PeerDAS case, because each node wouldn't have to build the entire matrix. They could just like select a random subset of the entire blob set and then just compute cells on those and publish those individually. So we kind of have like many nodes doing that at the same time, and we kind of get parallelization by default with that approach. But with 1D PeerDAS, it's a bit hard to do that. So we would need to do parallelization on each machine.
So I don't quite understand this, because for reconstruction, like definitely for 2D, it's more it's easier to see how to distribute it. Like that's kind of one of the reasons why we want to do 2D, that you can just reconstruct a single rows instead of basically needing to have everything to reconstruct. But for constructing the matrix in 1D, you actually can just encode each blob like by itself, basically. Like you could even, for example, say you're a local block builder, as the blobs come in the mempool, you know that you're about to be the proposer, you can just start encoding them and computing proofs for each blob. Like you don't need to have all the blobs to be able to compute the encoding and the proofs. But for 2D, you actually need to have everything before you do anything. Or like you can extend each blob, but the vertical extension for the 2D thing, you can only do it once you have all of the blobs, basically, all the extended blobs. So you can only do kind of half of the work in a clearly distributable manner. Like at some point, you need to do also the vertical extension, and that seems like it's harder to distribute. I don't quite understand why you say that block construction is more easily distributable in 2D.
Yeah, so the experiment that I'm doing right now is to have supernode special blob from EL and construct the cells and the column side cast for them. But the problem right now is that we transmit the blobs in the unit of data columns rather than cells. So if you want to send one data column to our peer, then we need to have all the blobs. Does that make sense?
Yeah, okay, yeah, sure. In terms of propagation, yeah, I mean, you do need to, yeah, get the whole column, but you can do all of the computation blob by blob, like all of the actually encoding and computing proofs Though, yeah, you can't send them out. But I mean, one thing that I don't think that this would necessarily change with 2D, just because, yeah, the idea was that 2D would have sampling being by cell, so that you could like, yeah, send these small parts. But still, I think distribution will very likely be with bigger chunks. Like that was still meant to be like by rows and columns in the kind of original design. But another thing is that to even have the cells, to begin with, you still need the whole matrix to and like have done the computation on the whole matrix, which is I think harder to distribute actually. Like you can't do you can encode all the blobs, but then only once you've done that you can even start doing the vertical extension.
Right, I see. Is it like, would it be beneficial if we could like break down like the data columns so that we can just send whatever cells we have in that column rather than having to send the entire unit at once? Because I think what you're talking about is the what's happening on the proposer node, right? The proposer can start preparing for the cells as soon as they have the blob in the EL. But if you wanted to like distributed construction, then the other node can only start building once they have the block and they have the blob in the EL, right? So they will have to do everything at once.
So in
And
so in the version that that we were playing with, we always do distribution cell by cell. I mean, we've been playing with doing cell by cell versus column by column, but when you start to do recovery based on the 2D structure, you anyway need the cell by cell distribution. So just based on that, we usually said, let's do it cell by cell from the beginning. But there were others doing more row and column-based distribution in the 2D case, and then kind of doing cell by cell for recovery and for sampling. That's for the networking part. For the generation, I think the difficulty is that you need the KZG commitment against which you verify on the column dimension. And to have that commitment, I think you need all the basically half of the elements of the column. So basically all the column. Yeah, but I have to think about it.
I'm a bit confused on what we're talking about here because we don't have column commitments. We only have row commitments. And also, I feel like if we start propagating cells instead of columns, we're gonna run like propagating entire units is nice because you don't have to worry about all the race conditions and all the edge cases of what happens if I get some but not all. Whereas if we start sending just cells, we need to start like we will get there will be much more complexities, I feel like.
Yeah, okay. So one thing is whether we have column and row commitments, and you're right, it's only row commitments. So you can verify actual individual cells just based on that. So that's not an issue. On what is being propagated, I mean, cell by cell might seem like more complex than only rows and columns. Like rows and columns might seem more complex than distributing the whole block. I don't see a huge difference in complexity, but yeah, but let me know what complexity you see in cell by cell distribution. It's, I mean, from my point of view, the efficiency gain was the complexity, and the complexity is not that huge, but yeah, views on that might be different.
Yeah, I'm not sure. I think it is very similar to when in 4844 we had to decouple the blobs and that came with its own complexities. But yeah, I don't want to make a statement about this because I just felt like when we decoupled things in 4844, it was more complicated. But I think, yeah, I'm not sure where to draw the line.
Yeah, I mean, I think it's a trade of a compromise that we have to understand well later on when we are potentially going into this direction. We have been running simulations, but those are high-level simulations first on cell by cell versus line by line, so rows and columns, and there are efficiency gains if you do cell by cell for a few reasons of peer-to-peer networking. But there are simulations with a few assumptions, which, you know, how it plays out at the end is still to be verified.
I think I'm not quite sure. I have kind of lost the connection between this discussion and the original question, which was about local block building and stuff.
Yeah,
I don't know if we have gone a bit side.
Yeah, I think it's kind of related, but the original question was like how many blobs can we realistically produce on a node in a block? I think when we hit 32, going above is going to require more than parallelization on a single machine. But it's worth experimenting. I think like if we do 64 and we don't have 64 cores, then it means there will be batches of like computations, right? So it will take longer to compute the proofs. So I think I was trying to think of ways to see if we can distribute the workload. So that's how we kind of drift away from that initial question.
Yeah. So it's scaling at one point requires distribution, especially if you want to have also enable smaller nodes to build somehow, and that's how it fits in. But yeah, I think it's longer term research.
So I think one thing is worth differentiating though is like there's kind of two components to local block building or block building in general, and like the complexity that blobs introduce. And one is the networking part, and one is the computation part. And the computation part, at least, there is nothing in the current structure that makes it harder. Like actually, I think the way that it is right now, it's as easy as it can be. Like it's perfectly parallelizable. And I mean, of course, yeah, if you hit the limit of you have more blobs than cores, yes, you will have to still do it in batches somehow. But there's kind of no way to do better than this. Like there's no way that, you know, going to 2D doesn't help with the computation. It can perhaps help with the networking, or at least like changes like, you know, not distributing columns could help with the propagation part. But on the at least computation part, maybe, yeah, the one thing that you can still do is, even if you don't have enough cores for the amount of blobs, you can still distribute the workload over time, just because blobs will not come right as you're proposing. Like you're not gonna get like 32 blobs immediately the second that you're proposing. You get them in the mempool over a few seconds, and you can just kind of distribute the computation over that period of time. So I think in principle, yeah, even a node that doesn't have too many cores should be able to do a lot more blobs than you would think, just based on the number of cores. Like you can, you know, you get blobs at 6 seconds into the previous slot. You have a lot of time to do the computation for those in advance, basically. But yeah, but I mean, these things, I guess, eventually, like there's like a bunch of like of these tricks that probably eventually should be implemented. For the propagation part, one thing that we've kind of discussed is that eventually it would be nice to basically allow nodes to just send out the block first without trying to immediately propagate blobs. And like basically, you know, once they've sent out the block to all their mesh peers, then only then start trying to propagate blobs. And basically, trying to use the fact that there will be nodes that have all those blobs already. Like if you have any kind of supernode peer or like supernode in the propagation path, they will be able to get all the blobs from their mempool if you're like a local block builder and have been building stuff from the mempool, and they'll be able to basically just do the reconstruction and start propagating things for you. So I think eventually it would be nice to basically try to use this as a way to have local block builders not have to do all of the propagation work, or like basically be able to rely on other nodes to help them with propagation, only kind of being able to do as much to go with as many blobs as they can deal with on the computation side, even if that's not necessarily what they can deal with in terms of propagation.
Yeah, thanks, Francesco. I've just linked a PR that basically does exactly what you just described. So I think so there's actually two different angles that you can think about this. So one, from a proposer side, we can definitely distribute the computation over time, like during the entire duration of the slot. But if we want to use the distributed computation, like using other supernodes to help with the block building and distribution, then basically each supernode that helps with the computation will have to construct all the cells. So I think there's a limit on how much we can scale in terms of number of blobs. So that's why I was kind of thinking if we can just have each supernode construct a subset of all cells. But I guess that's like further research required, I think. But yeah, I think we'll probably hit this problem once we get to 32 blobs. It'll be interesting to see what happens.
At least I would suspect that the networking problem would be fine. We would hit the networking problem much sooner than the computation problem, just because I don't know, if you have 32 cores, you can, even if the blobs were, I don't know, 128, you could do this in less than a second. Still, I mean, of course, like using all of your core time, but like it seems at least like, fairly manageable numbers, especially because we're not going to have 120 blobs for a very long time. So it seems to me that in like the foreseeable future, it's unlikely that the computation part would be the bottleneck, even for like pretty low power nodes.
Yeah, thanks. Sorry, I think probably went off topic for a while, but yeah, I think that's good discussion.
Thanks, Jimmy. Any other topics for discuss today?
Just want to make sure that V3 metadata should be in Devnet too. Does everyone else does anyone disagree?
We have metadata version 3. Any other topics?
Yeah, I have like a small question for something like a potential, maybe eventual spec change related to validator custody. If it was useful for this validator custody thing, would it be a big deal, like much of a problem to basically replace the custody subnet count thing with like a bit field? Like I think we have that for attestation subnets, right? Like something where you just say which subnets you're part of instead of like this custody thing where you just say I'm in 10 subnets and then deterministically compute which ones. If it was helpful to explicitly state which, would that, I don't know, be like an easy thing to do? Are there any challenges that kind of come from that? I'm just curious if it's something that I can consider as part of the design space or not.
What do you get from that?
Right now, nothing. Like in the current spec, there's no reason to do that. It's it's related to if we wanted to do this accountable validator custody, which works a bit differently, and the assignment that each validator have wouldn't be a public. It wouldn't basically would not necessarily be able to compute deterministically which subnets someone is supposed to be in based on their node ID. But like, I guess, don't worry too much about the why. For the moment, it doesn't do anything. I'm just wondering if there's reasons to like not want to do this, were it to be useful for other things.
I think one downside is that it will become easier for the attacker to map the validator to the node, right? So it's like, because you put more information in the ENR.
But in this case, it's the custody subnet count still allows someone to exactly know which subnet someone is in. This thing would be the same, just that you're explicitly stating which subnets you're in instead of stating something that then has to be fed into a function. And it wouldn't be actually, the idea would be that it's private what a validator is assigned to. So there's no public assignment of a validator. So it's I'm kind of really just mean to ask about this bit field thing, like if that in itself has some downside.
So with the current assignment, it would be the same information disclosure. As a bitmap, if you think of a potential future where you have 500 plus 500 rows and columns, then you are having a bitmap of 1000 bits, which I don't know if it's a problem or not, but it's definitely more data than the current count, for example. So it's a question of ENL size, I suppose.
Well, for us, it won't be an issue. We already do this for attestations and sync subnets, so it's pretty much, I think, the same thing. I also think in some sense it would be better to do it this way rather than having a subnet count, because for all the other attestation sync subnets, we have a bit field for those topics. So, standardizing it on just having bit fields for all of them I think is a rational idea.
Any other comments? Okay, so Francesca, we move on from here. Oh, good. Okay, any other topics for today? No?
Sorry, actually, another quick question. I'm just curious, what is the roughly like ratio of supernodes to non-supernodes that's been done in devnets, or like that you plan to do in this devnet?
Half.
Okay, sounds good.
We can do any other, if if there's a request to do something different. we
I
can do
just
something
think no, I think that's fine. I think it's just probably it doesn't make sense to do like something super low, just because eventually if we do have validator custody, there should be like a reasonable number of supernodes in the network. But yeah, half sounds perfectly fine.
Yeah, we don't have too many nodes right now, so that's another possible bottleneck that we have a very few nodes, and it's going to be very hard to have all the custody requirements fulfilled with the number of nodes that we run, basically, if they are not super nodes.
Does it make sense to increase the custody requirement before we have validator custody? Because right now we don't have validator custody, and the default is four. I think just 4 for the custody subnets. So I was wondering if it makes sense to increase it to 8 before we have the validator custody.
I don't know if the question is to me, but yeah, I guess to me it seems like it could make sense. But yeah, I think I don't know. I'm not sure what the specifics of the like how many nodes are there in the network roughly.
10 to 12, like we can maybe bump it up to like 20, but
Okay.
I don't know if you're gonna
I
see
see.
any benefit unless we run like hundreds of nodes, but
Right.
those just very expensive.
Okay, yeah, I mean it's I don't know. It's hard to I have to think how do things map to this kind of world? I'm not sure.
Yeah, I've had a comment in the chat. I think the biggest like problem on a small DevNet is that most of the requests go to supernodes, so there's less pressure on the regular full nodes, and we're always sending stuff to supernodes. I'm not sure if it helps if we increase it, if all the full nodes share the load. But something to think about. That it's a config change in the kurtosis anyway.
Sorry. So you want to do context switching, or what? What did you mean by that?
Oh, sorry. I was just wondering if it's worth having the network have a default custody requirement of 8, which is the default for validator custody in the future. Just because we only have 10 to 12 nodes, and currently all the RPC requests go to supernode.
Wouldn't it still be the case though, if you have higher custody?
If we have a higher custody, then there are more peers that we can request from for a given column. But I guess that doesn't really make a lot of difference. Yeah. For small network.
We could totally do that for the DevNet, but I don't know if we need to change the spec for this. Like we could just override that value and then unless this is hard coded to any client, which it really shouldn't. But you can also modify this value in kurtosis in each of your runs. There's a flag for that. So yeah, we can definitely play around with that. Yeah, because I remember last time when we were running some syncing test, and all the supernodes got like peer limited. I'm not sure if this was like the root cause of that.
Yeah, hopefully that's fixed now. Hopefully we don't DOS any other supernodes now. But it'd be nice if you had more PS to try from.
Yeah.
So any other topics for today? No? Okay, so we have the okay, PeerDAS updated the Devnet 2 document by the end of this week. Okay.
Please let me know if I should use a different branch than whatever we defaulted to. And then I can run some local tests. And then we can launch Devnet by the end of the week, hopefully.
Thank you. Okay, thank you for attending, and let's go back to work. Thank you. Bye-bye.
Hey.
Right.
Thank you. Bye.
Bye, guys.
Goodbye.